You.
Hello, everyone. So we're going to go over week 9's group problems. So here we have a beautiful picture. Yeah, you can see that. And so in here, we're going to go over the required parts of the diagram. And so as we can see, the ORIC is right here, and it shows that it's this whole section. We have the DNA primase, which is right there in pink. DNA helicase is here in teal. So that's the thing that separates it. The RNA primers for the leading and lagging strands. There's one right there. There could be one right here. There could be one right there. Could be one right there. All good places. So two leading strands. So right there's a leading. Here's a lagging. There's a leading and lagging strands. DNA polymerase 1. I think that's the one that I didn't actually write on here. Where would we find it?
Polymerase 1.
Would we right around here?
Polymerase 1 it's between the lagging strands.
Yeah, it's right here.
Yeah.
Perfect, right next to our Owazaki fragments, which are found in olive.
The lagging strands.
Yeah, in the lagging strands. And then DNA polymerase 3A subunit is right here in brown. Cool. Here's our pretty picture. I'll take us number 2.
All right. So for number 2. Okay. So 2A, the answer is DNA polymerase alpha and DNA primase. B is DNA A. E is epsilon. D is also epsilon. That threw me off for a while. Anyway, E is TUS. F is DNA polymerase 1. G is DNA gyrase. H is ORC. I is SSBP. And J is DNA ligase. And that will bring us to question 3.
Okay. So for 3A, okay. For 3A, we have DNA helicase, DNA gyrase, whatever, DNA primase, DNA ligase, and DNA A. For part B, we have DNA polymerase 3, DNA polymerase 1, alpha, beta, and gamma. For C, we have DNA polymerase 1, 2, and 3, alongside epsilon, gamma, and there's a few other ones that you could put there. For D, DNA primase, and then for E is telomerase. Number 4.
Sweet. So, thank you for your wonderful video that you made. So I'm just kind of going to go over it because we can watch your video. And so what we're going to do is take the primer that we have, and since we're not going to put that in, we need to flip the primer to be in the correct direction and then find the spot in the DNA sequence and then write out the section that does not include the primer. So for that we have 5 prime, ACT, GA, T, GG, T, CC, TGC, TAT, 3 prime. And so for B, we are missing the C nucleotide. So for that, we could only do 5 prime A, 3 prime. And for C, we're missing the T nucleotide. So we can only do 5 prime AC, 3 prime. And D, we're missing the CT, 3 prime. And that is question 4. Here's question 5.
All right, let's bring it to the end. Okay, so which of the above proteins is found in prokaryotes? So of those, we only have gyrase, TUS, DNA, DNA primase, DNA polymerase 1, and DNA polymerase 3 alpha subunit. And then B, which of them is found in mus musculus? You guys threw me off on this one. Mus musculus is a eukaryote, so it had the eukaryotic proteins. Those are DNA gyrase, CDC6, polymerase epsilon, primase, MCM helicase, DNA polymerase A, as opposed to DNA polymerase 3 A subunit. The polymerase A is part of the collection of proteins that eukaryotes have. Yeah. Anyway, telomerase, PC, and A. And that is B. So now C. Which of the above proteins is involved in chromosome compaction? The answer is none of them, because in DNA replication, the two strands of DNA are wrapped around each other like this. So they have to separate from each other so that the new strands of DNA can be added to the old ones. So all these proteins do not help with compaction, they do the exact opposite. They help with separation and synthesis of new DNA strands. Okay, now D. Which of the above proteins is involved in the initiation stage of DNA replication? So I said it was DNA gyrase, DNA, DNA primase, and pCNA. And arguably you could include MCM helicase, but I said no because it stops initiation. So you could argue either way, but I would argue that it's not. Anyway, and then D is TUS and telomerase. Those are the ones that help with the termination. TUS is in prokaryotes and telomerase is in eukaryotes. Okay, that's anything else you want to say?
Happy weekend.
Yes.